Hello everyone. In this video, we will understand the complete architecture of a database management system or DBMS. We will first look at the basic architecture and then explain each component shown in this diagram. The basic DBMS architecture consists of three main components. The first component is users. The second component is the query processor. The third component is the storage manager. The users send requests to the query processor. The query processor understands and processes the request. It then passes the request to the storage manager, which accesses the data stored on the disk and returns the result back to the user. Now let's understand the complete architecture shown in the diagram. At the top, we have four different types of users. The first is the naive user. These users interact with the database through forms or applications such as ATM users or online shopping customers. They do not write SQL queries. The second is the application programmer. They write programs using programming languages like Java, Python or C++. And these programs access the database. Third is the sophisticated user. These users directly write SQL queries to retrieve or manipulate data. Finally, we have the database administrator or DBA. The DBA designs the database schema and manages security, controls user access, and maintains the database. Now let's move to the query processor shown inside the box. Different users send different types of requests. Application programs containing embedded SQL first go to the DML Precompiler. The DML Precompiler separates SQL statements from the programming language code. The program is compiled separately, while the extracted SQL statements are sent for further processing. Users who directly write SQL commands send them to the DML compiler. The DML compiler checks the syntax and converts the SQL query into an internal form that the DBMS can understand. The DBA sends database definition commands like create, alter, and drop to the DDL compiler. The DDL compiler processes these commands and updates the data dictionary, which stores metadata about the database, such as table definitions, attributes, constraints, and user privileges. The output of the DML Precompiler and the DML compiler are then sent to the query evaluation engine. The query evaluation engine is responsible for executing the query. It selects an efficient execution plan and requests the required data from the storage manager. Below the query processor is the storage manager shown in the box. The storage manager acts as a bridge between the query processor and the physical database stored on the disk. It contains the three important components. The buffer manager manages the buffer in the main memory. Frequently used data is stored here so that the DBMS does not have to access the disk every time, improving performance. The transaction manager ensures that the multiple users can access the database safely. It maintains the ACID properties and keeps the database consistent even if failures occur. The file manager manages the physical files stored on the disk. It organizes, reads, and writes database files whenever requests are made by the query evaluation engine. Finally, at the bottom of the disk storage, it contains four important types of information: the data files, It stores the actual record of the database. The indices provides fast access to the records, reducing the time required to search data. The statistical data stores information used by the query evaluation engine to choose the most effective and efficient query execution plan. The data dictionary stores metadata about the database. It is updated by the DDL Compiler and contains information about the table, attributes, constraints, indexes, and user permissions. Let's summarize the complete flow. A user sends a request. The request enters the query processor, where it is processed by the DML Compiler, DML Precompiler, and DDL Compiler. The query evaluation engine executes the query. The request is then sent to the storage manager, which uses the buffer manager, transaction manager, and the file manager to access the required data from the disk. Finally, the result is returned to the user. This layered architecture makes a DBMS secure, efficient, reliable, and capable of handling multiple users simultaneously. Thank you for watching. In the next video, I will study each component of the DBMS architecture in detail.